Look, healthcare burnout right now is literally at an all-time high. Doctors are drowning in paperwork, spending countless hours just clicking through electronic health records instead of, actually talking to patients. And the big proposed solution? Autonomous AI agents that can run these hospital databases for them. But before we just hand the keys to the hospital over to artificial intelligence, there is a shocking reality check we need to confront today in this explainer.
Because here is the mind-blowing truth. When you drop the absolute most advanced, state-of-the-art AI model on Earth into a realistic clinical setting, it completely fails more than half the time. It caps out at a 46.3% success rate. But there's a massive catch as to exactly why it fails, which we'll get to in just a second. I mean, you see the media hype every single day, right? AI passing the medical boards, AI diagnosing rare diseases. But can an AI agent actually sit at a desk, navigate a completely messy hospital system, figure out what's wrong, and successfully order a treatment without a human holding its hand? Well, by the end of this explainer, you're going to understand exactly how this technology works and exactly why it is breaking down behind the scenes.
Part 1. The multiple choice illusion.
To really grasp the breakthrough we're looking at today, we first have to understand the illusion we've been living under. For years, the old way of testing medical AI was basically just giving it a static multiple choice test, kind of like the US medical licensing exam. And honestly, this created a dangerous illusion of competence. Think of it like a written driving test. The AI is absolutely brilliant at reciting the rules of the road. It has incredible book smarts, but driving in rush hour traffic, that requires street smarts. So the breakthrough here is a new framework called PhysicianBench. It completely ditches the written test and puts the AI directly in the driver's seat of a real electronic health record simulation.
And this quote right here brilliantly illustrates the core problem with those old benchmarks. Answering a static question about a symptom is a completely different ballgame from actually executing a long sequence of actions. A real doctor has to hunt down lab results from last week, synthesize that with a specialist's note from yesterday, decide on a treatment, and then physically navigate a complex computer system to order a medication. The old tests simply didn't measure any of that.
Part 2. Enter PhysicianBench.
So how do we actually test if an AI has clinical street smarts? Well, think of PhysicianBench as a literal flight simulator for AI doctors. Let's break it down like you're 5. The AI is dropped into a secure fake hospital computer. It gets a prompt, something like, hey, a new heart scan just came in for a patient. The AI then has to dig through the patient's files, figure out if there's a problem, decide what to do, and write the actual prescription. And then it gets strictly graded on every single move it makes through a system of checkpoints.
Now, for those who want the actual technical terminology so you can sound super smart, the AI is essentially navigating a partially observable Markov decision process, or POMDP. Basically, it doesn't get to see the whole patient record at once. It has to issue specific tool calls to retrieve data, assess the pathology, evaluate the clinical risk, and finally execute right actions to document and order the treatment. It is completing composite workflows step by grueling step.
Let's look at the sheer scale of the simulator. It consists of 100 incredibly complex, long-horizon tasks. And these aren't just made up by computer scientists in the lab. They're derived from real, physician-reviewed electronic consults from Stanford's clinical data warehouse. And the AI can't just be good at one specific thing. It has to operate across 21 different clinical specialties. We're talking everything from cardiology and endocrinology, all the way to psychiatry and oncology. To show you just how complex this environment really is, it takes an average of 27 individual tool calls just to complete a single task. That's 27 distinct steps of searching, reading, reasoning, and writing, where a single tiny mistake can derail the entire process. And the secret sauce making all of this possible is the FHIR API. That stands for Fast Healthcare Interoperability Resources. It's the standard API framework used by giant commercial EHR vendors like Epic and Oracle. This is absolutely crucial because it means the AI isn't just playing a simplified video game. It's using the exact same digital infrastructure that real human doctors use every single day.
Part 3. The 46% ceiling.
So the stakes are set, the simulator's built. When we look at the results, researchers tested 12 top models, and it is a brutal reality check. GPT 5.5 completely dominates the pack, but it still crashes and burns, only passing 46.3% of the time on the first try. Claude Opus 4.6 trails behind at roughly 32%. And if you're rooting for the open source community, the top model there, DeepSeek V4 Pro, maxed out at under 19%. But here's the really interesting part. Why are they failing? You probably think the AI just gets lost searching the massive database, right? Wrong.
Data retrieval only accounts for 12.4% of the failures. Clinical reasoning is the biggest single bucket at a massive 50.4%.
That's the average across all 12 models tested, not any one specific one.
But that's not the whole picture. Action execution accounts for another 18.8%, and documentation errors make up the remaining 18.4%. So even that 50.4% reasoning number is only half the story. It's failing at complex, multi-step medical interpretation, but it's also fumbling execution and paperwork on top of that.
When we dive deeper into the root causes and compare our top two contenders, GPT 5.5 and Claude Opus 4.6, we see that the failures actually concentrate in incomplete reasoning or near misses. It's not that the AI is confidently giving completely wrong, fatal diagnoses out of nowhere. It's more that it gets into the right neighborhood, but then forgets to specify a medication dosage or completely misses a vital safety caveat.
So why did GPT 5.5 win out by such a wide margin? Interestingly, it wasn't because it magically possessed more raw medical knowledge. It won because of its behavior. It showed superior data grounding, meaning it relied on literal data found in the chart rather than hallucinating facts. But here's the specific finding.
Outright wrong conclusions are rare for both models, and when either one commits to an answer, it's rarely wrong.
The gap was completeness. GPT 5.5 reliably hit every required item on the clinical rubric. Claude Opus 4.6 covered fewer of them. Same ballpark of reasoning quality, different rate of leaving something out.
Part 4. Real World AI Implications. So what should you actually take away from all this? Let's look at the real-world implications for the next 12 months. A 46% success rate clearly means we are not handing the hospital over to AI agents anytime soon. While these large language models have incredible book smarts and can pass written exams with flying colors, deploying autonomous agents requires a level of consistent, flawless execution across multiple steps that we simply haven't achieved yet. The gap between answering a medical question and executing a clinical workflow is massive. Which leaves us with this final, absolutely critical thought. In our race to solve healthcare burnout, are we rushing autonomous clinical agents to market way too quickly based on the illusion of multiple choice tests? PhysicianBench proves without a doubt that we need to demand rigorous, street-smart testing before we ever trust AI with real patient workflows. I really want to know what you think about this. Drop your thoughts down in the comments below. Thanks for joining me on this explainer, and as always, keep questioning the hype.